Hi, I'm a material scientist and also the synthetic chemist. And today I'd like to talk about how can we design of the material in principle to apply for the future energy devices. Okay. So there are various types of the future energy devices, and one of the typical, the examples is like fuel cell. Many people would like to develop on like a fuel cell-based vehicle, and actually at the 2014, one of the biggest company of the vehicle in Japan launched on the pure fuel cell vehicle named Mirai. Is for the English meaning is for the future. And the reason why that is a really like innovative technology for the device is that as energy resources, we can only use the hydrogen gas, H2, and oxygen from the air, O2. And so we could do the driving for long way by using of the hydrogen gas and the oxygen gas. And after we do the driving, only that the byproduct after driving is the water, H2O. So you could understand of the like how clean it is after the driving actually. So every people are expecting to develop this kind of like a dream-based technology in the future with their fuel cell. But actually there are many issues to develop this kind of technology for much wider application. Before talking about some of our research, I would tell a bit more detail about the mechanism of the fuel cell in the vehicle. As I say that as an energy resource, we use like a hydrogen and oxygen. But of course, this is like a technology and a device to generate of electricity to do the driving. So we input that the oxygen gas and the hydrogen gas from the both sides of one device, and then generate H2O with the electricity. So it is like some scheme of the fuel cell in the like vehicle, but you could see in the real middle of the device, you can find of the part which needs to transport of the hydrogen ion H+. This is very important to have a nice performance for a fuel cell. So again, I'm saying that's the material to transport of the hydrogen ion in the fuel cell is very important for the more development of this technology. Okay, please remind of this point. So when we think about the material design for the hydrogen ion transporting, one of the most simplest that molecules is water, H2O. Because as shown in here, water is H2O, but if these molecules are assembled, that each molecule of the water provides of the H+ to transfer each other, and then eventually we can have a hydrogen ion H+ transportation in the water. So it is the easiest, cheapest technology, but for the next generation fuel cell vehicle, the one big issue is that the temperature, okay? Temperature inside of the vehicle is above 100 degrees Celsius. So needless to say, water gets boiled, and then the oil evaporated, and we cannot use the water in the vehicle, okay? Temperature is very important. So we need to develop on the new material to transport over the hydrogen ion much safer way, and also which can work about 100 degrees C, okay? So we do chemistry and also the synthesizing of the new material. So, and we need some inspiration, like from somewhere else. And so we focused previously on the one of the like a big scale technology, and also the conventional technology, windmill, okay? And for example, in Europe, there are many like windmill with very large scale, and which generates of the electricity, right? When we see about a bit more detail about the windmill, And you can see like a rotating of the blade of the windmill by catching of the wind. And then it generates of the motive force, okay? And that kind of motive force is converted to the electricity by transducer, okay, here, to get the electricity efficiently. So this is an interesting example that like a windmill rotation can change to the electricity in the very large scale, like on the ground. So like it is kind of simple but inspiring for us to design of the material for a fuel cell. So in case of the normal like windmill, we could see like on the ground with about like 30 meters of the very large scale. But if we also see in the human inside, we could also see that kind of the windmill motion to generate of the energy, okay? So this is shown here, okay? So if we see about the membrane in the human, some of the like membrane contains of like some specific enzyme which is able to produce of the electricity with rotating motion of molecule, domain as shown here. So please keep in mind that even in the human, like a motion of the molecule starts to rotate and then starts to generate of the electricity with transferring of the hydrogen ion. So it's interesting. We could see that energy generation in the very big scale and also like a very, very small scale, we could see, like in this case of the membrane, the scale is about 10 to minus 8 meter, which is much, much smaller than the normal like windmill on the ground, okay? So, but we are a kind of material scientist. So with the inspiration of this kind of the energy generation, so challenge is how we can refer on this kind of the like a mechanism for the fuel cell again, okay? So please remind that we need a hydrogen ion transporter which can work above 100 degrees C without water. So, so if we could make new material, for example, like crystal, it's a very shine, like a transparent, beautiful crystal by a synthesis with chemistry, but that crystal contains of the nano size, let's say like 10 to minus 9 meter, like windmill motion by use of the specific molecule in the crystal. And then if that could produce that the hydrogen ion transportation, that can be applicable for a fuel cell. That's our initial motivation, inspired by like membrane-based like ion transferring system. So I'm showing several, we did several attempts to design such kind of the artificial, like intelligent, like windmill molecular-based material. And for example, in here, if we combine one metal ion, like zinc ion, and these two simple molecules, we could have such nice windmill type structure as shown here. So after the synthesis, we could get a very nice transparent crystal as shown here. But if we see very detail about the structure inside, you could see like a green triangle, which is coming from the one of the molecule phosphonic acid, which has a proton. Okay, and this crystal structure is really showing that this phosphonic acid group, which is pinned on the one metal ion, starts to rotate as a very small windmill to generate of the hydrogen ion transporting inside the crystal. So this is interesting and a good achievement by designing inspired by windmill from the bio and also the environment. So this is a kind of the movie what is really happening in the really nice chain crystal that we synthesize. And as I say, like proton containing molecule are aligning very high periodicity, and each of the molecule could rotate as a nano windmill as shown here. And you could see like a white like ball is that hydrogen ion can transfer one side to the other side only by rotation. We don't need to use the water. So like that's a good achievement. And actually, this kind of the material can be applied very nicely for the next generation fuel cell, which I'm saying in the middle part of the in the device. So, and one of the like, we have a very, very different types of benefits if we can have a very nice material. So one of the benefits for here is like usually in the very conventional, let's say conventional fuel cell that it launched on the 2014 by the company in Japan, one single vehicle uses like about 50 grams of the platinum metal as a catalyst, which is very, very expensive. And I would say like 1 gram is about 4,000 Japanese yen. And so of course that the total number of the platinum on the earth is really limited. So that prohibits on the much wider range of the application. But by use of our material, we could reduce that total amount of the platinum in a single vehicle from 50 gram, for example, to 5 gram, roughly speaking. So that means that we could make much more cheaper and much larger amount of the fuel cell vehicle, which is a very good innovation in the future. All right, so as a summary, so inspired by like normal like windmill on the ground to generate the electricity, and also that like windmill, let's say on the membrane in the body, we could design such a nice and correlated dynamic motion in a molecule inside the crystal, and which is able to transfer a bunch types of the energy, including hydrogen ion, okay? And that really contribute for the next generation fuel cell, which also be happy for us. All right, thank you very much.